Okie dokie. I don't know if this is streaming right now or not. I guess we'll find out. I don't know if my microphone sounds good. I don't know anything. I don't. I won't know anything unless somebody watches and tells me. So I haven't made any CAD cam things. I was doing Mastercam for a long time. This new shop that I'm working at, we're using Fusion 360. It's not that hard of a transition. I would say it would actually be harder to go from Fusion to Mastercam, but not the other way around. Just programming wise. Drawing stuff in here is fantastic. A lot better than Mastercam in my opinion, my experience. Uh, but although I do like Mastercam, it's more powerful. It has more multi-axis tool pathing and all kinds of cool stuff that you could do in Mastercam. But in Fusion, it's great if your shop is not producing a lot of multi-axis stuff. And when I say multi-axis, I actually mean like a full multi-axis movement, not just indexing. Because even like indexing on Fusion would be, pretty easy as well. Okay, I'm blabbering. So let's draw a part, and let's attempt to program the part. And just note that I don't have the full version of Fusion. This is just the free one that you could get for like learning or just messing around. But let's go ahead and do a lathe part because Fusion's not that great with lathe stuff, but it's capable of doing some stuff, right? It's not complete garbage. It could do a lot of it. So I'll finish that. Let's go ahead and delete this sketch. Let's create a sketch. Top view, yeah. Okay, we'll click there. And we're gonna do a revolve kind of extrusion thing. So we're gonna draw half our part, and then we're gonna use the revolve feature to make a 3D rendition of our lathe part. So let's make a simple lathe part. Like let's do like a top hat bushing. Yeah, it's all the rage, the top hat bushings, And then later on we'll make something more complicated. If you're new to like CNC lathes, new to lathes in general, like me, I started on mills and then I moved on to lathes. But I was terrified of the lathe. It moves fast. It looks like it's gonna crash. It's so close to the chuck. Everything, your boring bars, your drills, your live tools, anything that's like sticking out like axial wise, just looks like it's gonna smash right into the chuck, and it gets really close. If you're doing live tooling stuff, it looks very scary when you run it because the jaws come really close to the turret. Everything is super duper close, and you kind of just have to rely on your setup. Okay, and the programming is fairly simple on the lathe. It's a simple machine, but it's setup. Okay. Wow, I'm blabbering. I'm sorry. Okay, so let's do a quick top hat, like little bushing thing. So let's go ahead and we'll just do lines. Lines are cool. So 1/2 inch. Revolve, that will turn out into an inch diameter. So right now we're just working off the radius. Wrong place. Line. Let's go and let's make kind of a beefy flange. And then this part is going to be weird because I kind of want the ID to be 1/2 inch, but I want the OD to be 625, which is 5/8. So you would have a 1/16 of an inch wall from your OD to ID on the main part of this bushing. So what would that be? If I go 125, that's not good. If I go 188, that's 3/16, 187 and a half. Just 188's close enough for me. And we'll kick this out 3/4 of an inch. And then we will come down a 1/16 of an inch, and we'll go ahead and just draw that until it clicks back onto there. And we'll trim this and go ahead and go to our solids tab, revolve. We got that, and we'll select this axis, and now we have a little bushing. So to be honest with you, something like this, very easy to program on the machine itself. Unlike mills, CNC mills, those are kind of hard to, you know, what do they call it? Finger cam, because you always have to deal with your tool radius and push your tool path away from that. So you can't use like absolute positioning. You have to always compensate for the tool radius. The lathe, on the other hand, you literally just type in the diameters, and you could pretty much just type the numbers that are on the print into the machine, and you can make the part. I mean, you have to know the G code, but you could actually use the dimensions that are on the print to program your part. So let's say we don't know how to do that. All we have is Fusion, man. We gotta use Fusion, dude. Alright. So we'll go to manufacture, and we're going to do new setup. We're going to change it to turning and milling. So lathe is usually Z. It's coming off the edge of the part, and X is going to be your diameter. So we'll go ahead and leave it like that. We'll just make up like we have 1 1/8 inch for our diameter, and then for our length, we'll go ahead and leave it at 1 inch, and then I will offset from the front and leave that at 0. That I like doing that just for me when I'm on the machine. When it's Z0, I know that's the front face of the part, and then all the preceding dimensions will tell me that everything is correct, right? So it'll tell me like Z0, and then when you do like your finish pass or cleanup pass, it'll actually say like Z negative 750. So that's what I would do. You might be different. You may not give a hoot. You might do whatever you want. Nobody listens to me. I'm just kidding. Okay, so we'll go to the turning tab. Oh. My mistake. Oh, and right here. I like doing 0.1. The other one's kind of weird. I think it's metric or something. 0.1 offset. So your tools will automatically come to 0.1 away from the finish of the part, which is fine. and then we'll go ahead and change that back to 1 1/8, and from front. Okay, sorry. And then we'll do a face. So this is a lot of people they don't like the tool options that come with Fusion. This actually looks a little bit more robust than it used to. For this, let's go ahead and do setup or untitled, and then let's just create a tool. And what I want to do is create a OD turning tool. So we'll just type in OD turning tool. So this is kind of like the main insert that I'm always using. I don't know, other people might use different ones, but CNMG. And we'll go ahead and go into our insert. So C, 80-degree diamond, yes. 0 degree, yes. M, correct, right? And then if you go here, go to G. What? So when it comes to inserts are, they took me a while to get a grip on this, because they're pretty I don't know, just like the labeling of the inserts, everything means something and they're all stacked together, and it's just a big thing. So this would be a CNMG, and 432 is kind of what I'm looking for. Or we could do a 431, and that last number on the CNMG labeled stack is the tool radius. So this would be the first number, and we'll have a 1/2 inch included circle, right? It's a 3/16 thick, and so 1 is 1/64, and then 2 would be the 32 thou. So let's do 131, because our part is I just realized that the so I just noticed that it's not picking up the tool thing. So I may have to add another thing here. So if I assume if I do display capture, I could, yeah. So now you can see everything that's going on. I think I might have to shrink this a bit. Okay, we'll go there and there. Okay, and I think that's pretty much got. Let me see my Windows thing. Okay, I think it's pretty good here. Okay, so now you can see the tools. So all I did was I named it OD Turning Tool, CNMG. And then over here we made our insert, right? So CNMG 432, and it's a turning tool, inch carbide. Yep. Holder, we could design our holder. This probably won't make much of a difference, because you're going to be programming off your insert geometry and not so much the holder, but you just need to make sure everything checks out before you actually run anything on your lathe, right? I mean, it's not super hard. It's just, be careful. So we'll go ahead and select this tool. We have our face. So let's assume this is plastic or something, we could probably do like 1,000 SFM. But let's go ahead and just go 800. We'll just go kind of conservatively. And so most lathes have like a 3,000 RPM chuck on it, or spindle maximum speed. I rarely go that fast, and we'll just set our max speed at 250. So this, when you post the code, this is going to come out as G96 S800 M3, but before that is in your code, it should post a G50 S2500 RPM. So your spindle will not go faster than whatever you specify for your G50, which is your max spindle speed. And then we can go fast, just not that fast. And the thing with plastic is, like, if you, depending on the plastic, like if you're doing phenolic is hard. It's abrasive to your tools. So you could go fast, right? But your tool's gonna wear out, and your part finish might not look that great. But 10,000 of an inch per revolution is pretty mild. It's not super aggressive. It's not super slow, and it should go pretty fast. I mean, 2,500 RPM, 10 thou per revolution, should be pretty quick. And our lead in, lead out, we could probably leave that at 40 thou. Whoop. And yes, model front. So this, we could set our clearance height. I mean, look how far away that is. That's nuts. I like 0.1 is pretty good. And you're just gonna come in and I can get there real quick. And stock ID, yeah, that makes sense. So let's say we're gonna face this, and then I'm getting ahead of myself. We'll go ahead and go through these. This is just passes, and then we have outside to inside, inside to outside. Makes sense, right? Outside to inside, you're coming from the big part, going down. Inside to outside, you'll start down here and go up. I'm sure there's an occasion where you do inside to outside, but it would be rare, I suppose. Tolerance is 4/10, sure, whatever, it's just a bushing. And reduce feed rate. So you could reduce feed rate as you get to the center of the part, just for tool life, basically. But we won't need to do that. We'll leave that off. We don't need multiple passes. We'll probably stick this, have an excess of like 16 thou of an inch or 50 thou or something like that for facing, and so we could just leave all this. And then linking, full retract, whatever. Safe Z, override safe. And our linear, we could just do like a millimeter, 40 thou. So it'll come down, it'll face. So if we go ahead and simulate, it's going a little bit fast, ain't it? So just come in, kiss that front edge, go up, retract. So now we must decide if we want to drill before we take off all this material, because depending, your drill shouldn't push the outside wall out, but in some cases it can do that, and your OD of your part would be pushed out a little bit more. and this would be to size. And since it's plastic, it might push this out more, right? So I would say that we can go ahead and drill this part. Okay, drill through here. I guess we need to come in here and Fusion Library, drills, and come down, look for a 1/2 inch drill. We won't do any boring. We'll just say the drill's like super duper fucking on point. I guess. Alright. So it's a drill. It's a 1/2 inch drill. It's going through plastic. It shouldn't be too slow, but if you go too fast with plastic, you may not get the results you want, right? Okay. So let's go ahead and go to, let's say it's at 1200 RPM. So this would do your spindle G97. The S1200 and G97 is a fixed RPM, so it cannot speed up as you get down on your diameter. Surface footage is 157. We want to use feet per revolution, and let's do 5 thou. And I don't think we'll need to peck. It's not going that deep. Okay, we got our hole there, and drill through bottom, and we'll add about 50 thou just so it clears. Okay. So now we're faced. We have a hole. So now we just need to do a profile. So normally on something like this, I do like to leave a bit of meat for my finish passes, just so you can get under the nose radius of your inserts. Because if you're pushing material down to try to cut, it will leave a nasty finish. So we don't have a ton to take off of this, right? We're coming down to, about 5/8 from 1 inch. So I guess we could do multiple passes. So let's go ahead and do a turning profile roughing. So we'll come up here, pick the tool we made. So now we need to process this. Alright. So we'll start with the spindle speed again. One thing to note is you can save these things so you don't have to keep changing it. Like the maximum spindle speed, I would definitely save that if that's something you're always going to use for your lathe. And then our cutting feed rate, we'll just go ahead and do 0.01. And we'll come here, and then we should have our like 125. And I want to leave quite a bit on X. Leave a millimeter. And we'll use even depth of cut. We don't need packing. No dragging would keep it from going up the back wall. So it would come down instead of going up, which leaves a nicer finish, but we'll say that's not important. And we should be good. This thing always drives me nuts. What's it crying about now? Doesn't know what N is. to 0. Wow. Okay. Okay. So now we have 3 passes, you see. And the thing I kind of want to do is have it go back past the end of the part, just so our part off tool can come in and leave a bevel there or something. Which is, we should have put chamfers on the end of these, but we'll just ignore that for now. Maybe in the next thing that we do. Okay. What did I say I was gonna do? Oh yeah, go past the part. So back negative 0.125. And we want to come here and don't allow grooving, just so it goes straight back. Doesn't try to go down. All right. So then we'll do our finish pass. 500. Save that so it doesn't keep bothering me. And here we'll also do negative 1/8 of an inch for our part off tool, and we will come here and go ahead and do not allow grooving. Then here comes the part off tool, right? Whoop. For this one, I'll try to grab one of these. Is this metric? I don't know, metric. Okay, so it's saying it's an 1/8 inch groove tool. I'm sure it's fine for parting. We'll do 800, 500, and model back, yes. Edge break, yes. So we'll give it like a 20 thou. Oh. Yeah. And then if we come here, it would be model OD, and then it'll really add that chamfer. So back, the edge break. Doesn't need to be anything too crazy. Inner radius, we could go ahead and use our model ID, so we don't have to go all the way down to the center. So we can goes 20 thou down below. Transfer stock, no. Finishing pass. Distance below. Here we'll just do like 5 thou per rev. So now we should be able to get our bushing made in the lathe. Let's go ahead and simulate this. Going pretty slow. We can see what's going to happen. View, face, drill, and there it is. Nice little bushing. Easy beginner part for the lathe. Yeah, so that's pretty much it. I don't know what else to add. Maybe you guys learned something from this. If you want more Mastercam stuff, I could try to go back through it and show some toolpaths I haven't demonstrated before. If you want more Fusion stuff, let me know. I want to thank everybody that's actually watched my my tutorials and it's helped them. It's great. I love teaching people, so thanks guys. All right. Take care, boys.